Alright, so specifying a point in terms of r and theta. So we know two things that are really quite important for this part in particular. We know that sine theta is equal to y over r, and we know that cos theta is equal to x over r. Okay? So what we can do is we can use these two facts to actually find what point on a circle, or what an individual point on a circle is. So to do so, we can rearrange the subject of both of these equations for x and r by just multiplying both across by r. So it turns out the y-ordinate is just equal to r times sine theta, or r sine theta, and that cos, or x, is equal to r times cos theta, or just x is equal to r cos theta. Okay? So this is going to help us find what our x and our y individual parts are at any point of a circle, given the radius of the circle and an angle. So let's have a look at an example of this. The circle x squared plus y squared is equal to 64 meets the positive direction of the x-axis at A. Find the coordinates of the points, plural, P on the circle such that AOP is equal to 30 degrees. So the reason I pointed out the plural is because there's actually two solutions to this. There are 2 points in which I can make a circle. There are 2 points in which I can make a circle that has a ray, or that has an angle from the x-axis to a point, another point on that circle, which is 30 degrees. And I'll show you that right now. As soon as I can get a circle, I am happy with. Okay, so here's my x, here's my y. We know that this circle is 8, minus 8, 8, minus 8, if that was drawn properly. And we've got AOP is equal to 30 degrees. So here is my origin point here. I've got 2 points here and say here. Okay, because when I make my, and here's A here along the x-axis, when I make my angle, okay, so my angle comes along here and it shoots back up along here. Okay, so that's 30 degrees in there. Alternatively, I could have it so that the angle is in there, which is 30 degrees there. Okay, so the cool thing about this is that the x coordinate, so when I do my x and y for both of these, okay, my x coordinates are going to be the same because they're both the same amount of distance from the origin across to the x. It's just that the y is going to be different, and in fact, the y is only going to be different by a negative and a positive because it's only going to be the negative or the positive of it. So we're going to use our 2 new definitions to actually work out what these are. So x is equal to r cos theta, and this is how we're going to find our x. So if x is equal to r cos theta, so the radius of the circle, which is just equal to 8, okay, because 64 is r squared, so therefore r must be equal to 8. Cos, and then the angle that we've got. So the angle is 30 degrees. Okay, so all we need to do then is just put that into our calculator. So 8 times cos theta, so cos of 30 degrees, and that is equal to, putting it in my calculator, 6.93 to 2 decimal places. Okay, so we know that's going to be the same x point because it's the same amount of x units along. Now the y is only going to be different in the fact that it's positive or a negative. However, the way we're going to find it is still the same. So r sine theta, so y is equal to 8 times sine lots of 30 degrees. Okay, so y is equal to, so 8 times sine of 30, and that's equal to, oh, that's nice and easy, it's 4. Or it's also equal to -4 because of the other one. So therefore, 2 points that satisfy the above criteria are, okay, so 6.93, 4, and 6.93, negative 4. Okay, that's it for this one. Nice and easy. It's all pretty much done the same way, okay? So there's nothing that's actually different with this one, and I'll see you guys in the next one.